Hello everyone. Today I am going to demonstrate task 1, prediction using supervised machine learning. The problem statement here given is we have to predict the percentage of a student based on number of hours studied. Mainly the model follows 7 steps. In step 1 we are going to import a dataset. In step 2 visualize and analyze the dataset. In step 3 prepare the data. In step 4 design and train the machine learning model. Step 5 visualize the model. Step 6 make prediction. Step 7 evaluate the model. In step 1 importing the dataset. I mean I'm initially importing all the required libraries for building machine learning model. Pandas, NumPy, Matplotlib. Now, after importing all the libraries, I am going to extract the data set from the given URL, which is an CSV file. After importing it and printing it, you can see the data set printed here. Using data.shape, we can see the dimensions of the data. You can see this is an array which has 25 rows and 2 columns. In data.describe, we can see there are some numerical calculation performed like mean of the data, standard deviation of the data, what is the minimum value, what is the 25 percentage and what is the maximum value. The major part of this model to to clean the data. Luckily we don't have any duplicate values or null values in the given data. You can see, you can check it by using this dot null dot sum. Step 2. Visualize and analyze the data. Here I am plotting an graph between number of hours studied and scores of the student of using scattered plot. You can see there is a positive relationship between the number of hours studied and the percentage score. As number of hours increases, accordingly the score also increases. Step 3. Prepare the data. Here we are extracting the values of the data. Here x acts as an input uh, and y acts like a prediction for the output. Here, anyway you know that x is the number of hours studied and y is the scores of the student. Here I have printed the x values and y values. Now the second major part of the model is to train the data. First, I have split the data into test and train by using sklearn. Here I have used 20% of the data in the test and remaining 80% in the train. As we know, for better accuracy, taking larger part of the data in training set and smaller part in test set will give more accurate results. And I have printed them accordingly. Step 4. To design and train the machine learning model. I am using a sklearn linear regression model. Here I created an regressor object and fitted the x train and y train values in it. Step 5. To visualize the model. Here I have plotted the graph using a simple line equation y equal to mx plus c. You can see it. Step 6. Making predictions. Generally, predictions are made using testing data. Here I am using ypred and regressor object to predict the according testing data. You can see this. Using this pandas, I am going to create a data frame for actual value versus the predicted value. You can see this if a person who studied 1.5 hours has scored an actual value of 20 and we got a predicted value 16.88. Yes, there is a lot, there is a huge difference between it, but as we accordingly use more data, the difference also decreases. Finally, coming to the custom data given in the problem statement. Sorry, the custom input given in the problem statement. Here, we have to find a person scored how much for studying 9.25 hours. Here I am going to convert this 9.25 hours to a list and pass it through this predicted model. After doing this, I am going to print it. After printing, we can see the output that a person who studied for 9.2 hours will obtain a value of 93.69. Step 7. Evaluating the model. It is really very important to evaluate our model as it allows us to compare how well we have executed our algorithm. There are many ways for evaluating model. I have basically used three of them. Mean, absolute, error. It is nothing but finding the total mean of the given data and taking the difference between the predicted value. Max error. Max error is nothing but it is the maximum error in the given data set. Mean square error. It is finding the mean of sum of squares of differences between the actual value and the predicted value. So finally, I can conclude by saying that these 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 steps are the entire working of the linear regression model.